A group of SpaceX software engineers who hold various leadership positions in the Starlink team participated in a very enlightening Reddit Ask Me Anything session on May 15th. They gave us a deep look into the jaw-dropping software that runs on the Starlink network and discussed everything from Starship and Starlink to working at SpaceX. One Reddit user who had previously updated cloud servers wanted to know how difficult it must be for SpaceX to push updates out to an entire constellation of satellites. Natalie Morris, the engineer in charge of software test infrastructure for Starlink satellites, went ahead and elaborated on the entire software and firmware update process. According to Natalie, SpaceX tries to roll out new software builds to its entire fleet of assets, which includes ground stations, user terminals, Wi-Fi routers, and satellites at least once per week. Every device is periodically checked in with SpaceX servers to see if it's supposed to fetch a new build, and if one is available, it'll download and apply the update during an ideal time that minimizes impact on users. This means that software engineers can easily test builds on a small pool and move to much larger deployments by changing a few configurations in a database. One Starlink asset can contain dozens of separate computers, and SpaceX has designed its software system in such a way that each asset updates automatically by first fetching a new package to a central node and having all of the other computers fetch updates from that central node. Every device also retains a backup copy of the last good software so that if anything goes wrong during the update, say a powerful fault, it automatically recovers by booting into that backup. So yeah, your Starlink update might not be as straightforward as your typical iPhone update, but at least it's still smooth enough for you to barely notice. As you'd expect, Starlink has a complex and intricate telemetry system. A telemetry system is what facilitates data transmission between remote points over a network, which in this case would be the satellites and the fixed ground terminals. According to Christine Huang, head of application software for Starlink, the biggest challenge SpaceX has had to address in regard to fixed ground terminals is how to allocate satellite beams to every spot on Earth that they would want to serve. The Starlink engineering team takes into account field of view constraints, radio interference from other satellites including their own, and the number of users that need bandwidth. If you think that setting up Starlink on your boat or RV would give you a spotty internet connection, think again. YouTuber Tech with Shay demonstrated this by mounting Dishy McDishface onto the roof of his van and setting up the router inside. The result? Starlink works relatively well when moving. Christine added that motion does not generally add much complexity to the telemetry system. However, it presents some interesting challenges when it comes to satellites that are out of contact from the ground in parts of their orbit. This means that Starlink's telemetry system has to be resilient to out-of-order and/or late-arriving satellites. Moving targets require engineers at SpaceX to solve the altitude determination problem, which is the direction Dishy is pointing at, quickly and continuously. Changes in satellites also change the number of users in a given spot at any given time, which affects how much bandwidth is needed there. When the Starlink project was launched, SpaceX already had a great in-house telemetry system. The only problem was the existing telemetry system had a core concept of a run, which is a definite start and stop time for any given dataset. Starlink didn't fit that model because there are many devices that are always on and can send data out of order or with significant delay. These were some of the first problems that the software engineering team had to solve. Along the way, some of the more interesting challenges that the team has had have been around fault domains and fault tolerance, which is basically making sure that parts of the system have as much availability as possible. If one set of devices emits information that breaks expectations, its impact is limited to the smallest subset of software as possible so that other datasets can continue to be processed. And rather than storing all the data, the software engineering team created a powerful system to aggregate information over time as well as fade out information when it's no longer useful. One very commendable feature that Starlink has is the smooth and seamless transition between satellites when need be. According to Jeanette Miranda, a laser communications firmware developer at SpaceX, the Starlink software system is built to be super dynamic. With Starlink satellites moving faster than 4 miles per second, users aren't usually connected to the same satellite for more than a few minutes. Each user terminal can only communicate with one satellite at a time. So Starlink's user-to-satellite links utilize electrically steered beams to instantaneously change targets from satellite to satellite, and the software engineers temporarily buffer traffic in anticipation of this handover. Starlink's satellite-to-gateway links use mechanically steered antenna, so the engineers have to account for movement time and make sure they don't let go of one connection until they've securely established the next one. If you're a software engineer or developer, you're probably familiar with the occasional bug getting through every once in a while as you write new software. Now imagine working in an environment where a bug like that could cost your company billions of dollars in damages, or worse, lead to serious injury or loss of life. According to SpaceX's Jarrett Farnitano, you need a different mentality to work on such safety-critical software systems. The most important thing is making sure you know how your software will behave in all different scenarios. This affects the entire development process, including design, implementation, and testing. Design and implementation will tend to lean towards smaller components with clear boundaries. This enables those components to be fully tested before they're integrated into a wider system. That said, the full system still needs to be tested, which makes end-to-end testing and observability an important part of the process as well. By exposing information about the decisions the software is making in telemetry, the software engineers are able to automate the monitoring of the software. This automation can be used in the development, regression testing, and on the software running on the actual satellites in Starlink's constellation right now. That gives the engineers confidence that their software will work as expected throughout its entire lifecycle. We can't say we were late, but it's pretty obvious that running an in-orbit satellite constellation system comes with some out-of-this-world problems. According to Natalie, to manage a large satellite constellation without needing hundreds of human operators, SpaceX relies on software automation running on the ground and on the satellites, as we'd previously mentioned. In order to fully test their systems in an end-to-end configuration, SpaceX engineers have to integrate hundreds of different software services in a development environment. Another challenge the engineers face in testing is that it's not always possible to test every single capability with one test. For example, if SpaceX engineers want automated tests that exercise the satellite-to-ground communication links, they have to get hardware in the loop, or HITL test beds of the satellites, and then set up a mock ground station with a fixed antenna. From there, the software engineers can run a test where they simulate the satellite flying above the ground station, but they also have to override the software so that it thinks it's always in contact with their fixed antenna. This lets the software engineering team test the full radio frequency and network stack, but doesn't let them test antenna pointing logic. Alternatively, they can run pure software simulations just to test antenna pointing. You must be wondering how SpaceX's quality assurance team validates software developers and engineers, since they can't exactly fly up there and check things out. At SpaceX, they don't separate quality assurance from development. Every engineer writing software is also expected to contribute to its testing. The software engineering team generally tries to do as much testing before the payload rocket merge as possible on their high-fidelity hardware test beds. Their test codes and test results are peer-reviewed alongside the flight code to make sure that they're testing all the right things. SpaceX also has independent engineers developing end-to-end tests that stress the whole system. One cool thing about testing for a large-scale satellite constellation is that the software engineers can actually use canary satellites to test out new features. As the engineers run regression tests on the software to ensure it won't break critical functionality, they can also select a satellite, deploy the new feature, and monitor how it behaves with minimal risk to the constellation. So if after hearing all that you're still interested in becoming a software engineer for SpaceX's Starlink project, I've got some good news for you. The demand for brilliant software engineers and developers is always high. If you want to get a slight idea about what working at SpaceX is like, Christine Huang has you covered. According to her, engineers at SpaceX are both strongly encouraged to identify problems to solve and to own solutions to those problems from end to end. This means thinking through each option not just as an engineer, but as an architect, designer, developer, tester, and user, which is believed to lead to more elegant solutions. Software engineers at SpaceX are rewarded for increasing their scope, impact, and autonomy over time. From pioneering interplanetary human travel to providing internet access to marginalized and remote locations around the world, software engineers at SpaceX are clearly some of the most underrated heroes we have in the tech world. When do you think Starlink will be available to the general public? How small or large do you think SpaceX's development team for Starlink is? Will Starlink eventually compete with established ISPs? Let us Venus has been overshadowed by Mars in recent years, and some might say with good reason. Only 64 million miles away from the surface of the Sun, Venus is a rock of runaway greenhouse gases, meaning its surface temperature is astronomically high. The colonization of this inferno-like planet seems like a lost cause to many in the scientific community. However, it appears that the people at NASA are very optimistic and are even gearing up to go to Venus. While settling on the surface is almost impossible, the planet's atmosphere has a layer that is very similar to Earth's. This might actually make it a safer option for colonization than many people think. About 50 kilometers above the surface of Venus is an area of the atmosphere that might be able to support life. It has reduced pressure, lower carbon dioxide levels, and temperatures as low as 30 to 50 degrees Celsius. This layer of the atmosphere is probably more similar to Earth than anywhere else in our entire solar system, including Mars. The question is then, how does NASA intend to colonize a planet where we can't even land on the surface? Well, the answer is a floating city. A floating city would be ideal if we want to build a human home in the clouds of Venus. The air on Venus is so dense with carbon dioxide that air from Earth containing oxygen and nitrogen will act the same way that helium does on Earth. Think of a helium balloon floating into the sky, but instead of a balloon, it's an entire city. If these megacity structures were made with light enough materials and with the help of a few thrust engines, we could have ourselves a sustainable city in the clouds of Venus. Currently, the idea is to have spacecraft that look a bit like airships. Now, while this sounds like something straight out of a Star Trek movie to the rest of us, NASA has shown some serious interest. One of the reasons space agencies like NASA are so willing to attempt manned missions to Venus is because it's thought that Venus missions will have less radiation exposure than a Mars mission, which would mean less risk for astronauts. The space agency has already launched a project dedicated to the floating city concept called High Altitude Venus Operational Concept, or HAVOC for short, with a team of engineers already working on the project. NASA's Project HAVOC comes in 5 phases. The first phase will involve a robotic exploration mission by a 100-foot-long airship. It will be the testing ground to see if humans could really survive on a floating airship above Venus. It'll test things like the energy systems, but they'll also want to test aerocapture, which is a method of orbit insertion. Venus's atmosphere isn't a nice place. So actually getting an airship to comfortably sit 30 kilometers in the air is the first necessary step to take before we can even think of a manned mission. Phase 2 will be the first manned mission, but the astronauts will only orbit Venus in this mission. Phase 3 is where it gets truly fascinating. This is where astronauts will plan to descend into the Venusian atmosphere for 30 Earth days and live on one of the airships. This time, the airship will be 400 feet long and 100 feet tall. They wouldn't have all of this space to live in, though. The actual cabin where they would live is much smaller and will be attached to the bottom of the airship. These astronauts will carry out experiments and research 50 kilometers above the surface of Venus, where temperatures reach over 400 degrees Celsius. Once they've completed their 30-day stay, they'll ascend back into orbit using a Venus ascent vehicle, and from here, a rocket will take them back to Earth. This would be quite a long and dangerous mission. The journey to Venus would take 110 days, and the return journey would take 300 days, taking the total mission time to 440 days. Phase 4 is basically Phase 3 again, but this time humans would live on the airships for an entire year. Naturally, Phase 5 is planned to be the realization of a permanent human presence in the atmosphere of Venus. At this point, you'd probably have teams of scientists from different countries coming and going, a bit like the ISS. But how would you even power missions like these? It makes sense that solar power would be used to power the floating cities, keeping the lights on indefinitely and powering the thrusters that would need to run constantly to keep the cities from crashing into the surface of Venus. In the early missions, mostly non-solar power fuel will be used for the transportation of the astronauts to and from Venus. Who knows though, maybe NASA will find a way to get an alternate source of fuel from the surface of Venus using robots. Make no mistake though, there will be no colonization of the surface. Even the best space mission that was ever sent to the surface of Venus only managed to transmit data for just over an hour. The conditions down there are so hellish that even robots struggle to survive. First of all, the atmosphere is about 96% carbon dioxide, making it so dense that it's impossible to breathe or even see a few meters ahead of you. Secondly, the atmospheric pressure on the surface of Venus is heavy. It's about 92 times the pressure on the surface of Earth. It would probably feel like standing on the bottom of one of Earth's oceans with all that weight pressing down on you. After considering all these factors, it's easy to see why building a settlement or even an outpost on the surface of Venus seems a bit unlikely. Although Venus is only now receiving attention from the wider space community, it has a history of firsts in humanity's journey to the stars. Venus was the very first planet after the Moon to be visited by any spacecraft back in the 1960s and was also the first to be successfully landed on. A lot of this was done by Soviet Russia, which caused them to name it a Russian planet. NASA has shown further interest in studying the compositions of Venus by selecting 2 missions to probe and study the composition of the planet. The missions are part of NASA's Discovery program, and they aim at understanding why and how the planet became a gaseous inferno when it's so much like Earth. NASA announced it had chosen 2 finalist missions in its latest round of Discovery programs. The Deep Atmosphere Venus Investigation of Noble Gases, Chemistry and Imaging, which was fortunately codenamed Da Vinci Plus, is one of the missions selected by NASA back in February 2020 as part of its Discovery 2019 competition. Da Vinci Plus is aimed at studying Venus's atmospheric composition in detail by investigating how it formed and evolved over billions of years. The mission will measure the effect of greenhouse gases and possibly volcanic eruptions. Da Vinci Plus will also study the planet's surface to determine if Venus ever had an ocean at some point in its history. If there was an ocean or body of water on the planet, it would have all evaporated at this point, leaving only traces of riverbeds and ocean depressions. For scientists to study this, Da Vinci Plus will transmit the first high-resolution pictures of the planet's surface. The mission also aims to get a shot of what scientists have named tessera. Tessera on Venus are unique geological features that might be the equivalent of continents here on Earth, and studying them will help understand if the planet has plate tectonics much like Earth. The second mission to our sister planet will be the Venus Emissivity Radioscience INSAR Topography and Spectroscopy, codenamed Veritas. Veritas will work to map out the planet's surface from orbit to determine its geological history. This will help us understand how the planet evolved so differently from the Earth, even though both planets have a lot of similarities. Veritas will be fitted with a deep space atomic clock and a synthetic aperture radar, which will be used to chart surface elevations over the planet, creating high-definition 3D reconstructions of the surface topography. This will help to understand the planet's rocky surface and to prove if features like volcanoes still exist on the surface and if they're actively contributing to the highly acidic nature of the atmosphere. Veritas will also use planetary imaging to map infrared emissions from the planet's surface to understand its rock type and formation. This imaging will also tell us if volcanoes on the surface are still emitting water vapor into the atmosphere. NASA Administrator Bill Nelson made the following statement at NASA's State of NASA briefing.
These 2 sister missions both aim to understand how Venus became an inferno-like world capable of melting lead at the surface. They will offer the entire science community the chance to investigate a planet we haven't been to in more than 30 years.
Both missions are expected to launch sometime between 2028 and 2030, each with a $500 million budget. Also, with the potential discovery of phosphine in the planet's atmosphere by some scientists, the race to study the planet is on. Phosphine is a chemical substance created by organisms in anaerobic, oxygen-free environments, much like the atmosphere found on Venus. Some scientists think this might be evidence of alien life on the planet. While the theory is far-fetched for many in the space community, skeptical scientists are yet to provide an alternate cause for the production of phosphine on Venus. NASA Administrator Jim Brendenstein tweeted about the phosphine discovery. The discovery of phosphine, a byproduct of anaerobic biology, is the most significant development yet in building the case for life off Earth. It's time to prioritize Venus. Although Venus is a hostile inferno not ideal for human settlement, studies aimed at understanding her history and current state might provide evidence for the idea that Venus could be a suitable habitat for human civilization, similar to Mars. Elon Musk doesn't seem to think so. He views Venus as a warning that shows us what Earth could become in the worst-case scenario, and definitely not somewhere to call home. It's certain that the surface is far too extreme for human life, but perhaps we will have teams of scientists living in floating cities and conducting research. What do you think about Venus? Would you visit a floating city, maybe on a 2-week package holiday? Let us know your thoughts down in the comments section below. And be sure to give this video a thumbs up. Elon Musk's SpaceX has been the world's leading company in spaceflight and innovations for the past decade. It has successfully broken records set by government agencies and has repeatedly broken its own records. Elon Musk himself has seen to it that his company is well ahead of its competitors in every aspect of the aerospace industry and has made SpaceX a company to be copied. However, it seems a certain government entity has some special plans for SpaceX's innovative technology. The Pentagon announced it'll be launching an experimental program called Rocket Cargo, and it'll be led by the Space Force. The U.S. Space Force is the smallest and latest addition to the United States Armed Forces. It's currently the Space Division of the Air Force and the world's only independent space force. Its operations and activities are overseen by the Secretary of Defense, with its headquarters located in the Pentagon. With increasing public and private interest in space exploration, it was only a matter of time before the government created its very own military version of SpaceX. The department is charged with space security, mobility, information, and logistics. Its main focus is to advance the United States military capabilities using satellite and space vessels. Its mission statements include to provide freedom of operation for the United States in, from, and to space, to provide prompt and sustained space operations, protect the interests of the United States in space, deter aggression in, from, and to space, and conduct space operations. Being a relatively new branch of the military, the Pentagon Space Force doesn't have as many personnel or even vessels, boasting of only about 77 spacecraft at its disposal, as opposed to the Air Force, which has over 5,000 active spacecrafts in its fleet. As expected, the Space Force also receives personnel from the Air Force, which has over 300,000 active airmen in its ranks. This delegated staff help make up the agency's 4,000 personnel. Even with the right amount of funding, Space Force is still new to the space game, and its operations need a little assistance from companies with experience and technical know-how to help with its missions. To this end, the department has revealed that it's been working with aerospace giants like SpaceX. "We already work pretty closely with Elon Musk and SpaceX," said Lieutenant General David Thompson, the Space Force's second-in-command. Project Rocket Cargo will involve rockets landing on a variety of non-traditional materials and surfaces, which is oddly similar to something Elon Musk already has planned. Back in 2017, before the first Starship prototype was even commissioned, Elon Musk revealed his plans, or rather his dream of Earth-to-Earth rocket transport. At the International Astronautical Congress in 2017, Musk showcased a demo of what he intends to be point-to-point Earth travel using the Starship rocket, cutting flight hours to anywhere on the planet down to an hour or less. The idea was to launch the rocket with its passengers to an altitude somewhere in low Earth orbit, where air and wind resistance are virtually non-existent. This, of course, would allow the aircraft to exhibit incredible speed and enable it to cover over 10 times the distance of the fastest commercial airplanes at a lower altitude. To give us an idea of how fast these commercial rocket flights are meant to be, SpaceX presented some flight durations with the intended rockets, including a 24-minute flight from LA to Toronto, 30 minutes from New York to Paris, 25 minutes from LA to New York, and just 22 minutes from Hong Kong to Singapore. These are tiny fractions of the current flight durations and could change the concept of commercial air travel forever. Although back then SpaceX didn't reveal any specifics on the intended rocket for this kind of flight, we now know that the Starship is the only space vessel on the planet capable of this kind of commercial flight. Fast forward to 2020, when SpaceX's Falcon 9 rocket has had more successful launch missions than any other private or governmental rocket in history, and it seems the Pentagon wants a piece of the action. The agency reached an agreement with Elon Musk to make his plans of point-to-point space travel a reality. Under the new contract, SpaceX is to assess the cost and the technical demands of the project. The plan is to build a rocket capable of transporting 80 metric tons of cargo and payload anywhere on the planet in under 60 minutes. The rocket would be capable of reaching speeds of up to 7,500 miles per hour, which is unheard of even in the fastest-moving vessel in the world. General Stephen Lyons, head of U.S. Transportation Command, said at a virtual conference, "I can tell you SpaceX is moving very, very rapidly in this area. I'm really excited about the team that's working with SpaceX. The Globemaster, a military transport aircraft, pales in comparison to the speeds of the Starship rocket. The Globemaster, which costs about $218 million to commission, can reach maximum speeds of about 590 miles per hour, and it would take 15 hours to make a trip from Florida to Afghanistan, which the Starship would do in under an hour. Think about moving the equivalent of a C-17 payload anywhere on the globe in less than an hour," General Lyon went on to say. The capabilities of SpaceX's Starship are the blueprints for this project, but the Pentagon revealed that it is currently in talks with other aerospace companies like Jeff Bezos' Blue Origin to join in on the project. The Pentagon also intends to build on its relationship with SpaceX for more than just ultra-fast transportation. It also intends to improve its tracking technology through its interaction with Elon Musk's company. The government agency aims to use SpaceX's mega constellation of satellites to modify its GPS and geolocation systems for greater tracking accuracy. SpaceX's Starlink is intended to provide ultra-fast satellite internet access to every corner of the planet, especially rural areas without internet connectivity. The constellation is intended to feature over 42,000 satellites in low Earth orbit, making it the largest group of satellites owned by any government or private company. SpaceX currently has over 1,600 Starlink satellites in space, and the Pentagon wants to modify these satellites for better tracking of its assets, which would enable it to better pinpoint accuracy for public GPS. Todd Humphreys and Peter Iannucci, radiologists of the Radio Navigation Laboratory at the University of Texas, claim to have invented a new tracking system. The system would use these Starlink satellites, piggybacking traditional GPS signals to provide location accuracy 10 times better than current GPS, which only pinpoints to a few meters. Humphrey calls the system fused LEO navigation, and however innovative it is, each satellite can only cover a small area beneath it. Hence, it would need hundreds or maybe even thousands of satellites to be able to give global coverage. Building an entirely new constellation of satellites for this purpose would be an incredibly expensive undertaking, not to mention the years it would take just to get the satellites in orbit. Instead, Humphreys and Iannucci propose a different, less expensive approach. A minor upgrade to Starlink's satellite software programming improves its current GPS signal and boosts its communication strength. Furthermore, current GPS signals are weak and are prone to interference and jamming from cyber attacks. Humphreys' proposed new system claims it can boost strength, particularly using Starlink satellites. This is because Starlink satellites use a unique form of algorithm not found in most consumer devices, making it almost impervious to jamming and attacks. Since the Starlink satellites are basically large internet routers capable of connection speeds of up to 100 megabits per second, their signal strengths are 10 times stronger than current GPS. Since the Pentagon depends heavily on its ability to track its assets and hostiles, it needs this pinpoint accuracy. They told me the Army has a relationship with SpaceX, and would I be interested in talking to SpaceX about using their Starlink satellites the same way, Humphreys told the MIT Technology Review. They got us an audience with people at SpaceX who liked it, and the Army gave us a year to look into the problem. The Pentagon is currently funding Humphreys' research in collaboration with SpaceX, investing millions of dollars in the project. The project is still in its developmental stages, as SpaceX hasn't made any final commitments to it just yet. SpaceX's continuous technological improvement and innovation have made it the go-to company for the United States Departments of Defense. The Pentagon has shown that instead of just copying SpaceX's technology, it would be better to work with the company to assure a safer America and ensure world peace. Do you think SpaceX and the Pentagon will be able to work together? Or will it be another failed contract ending up in a multi-billion-dollar lawsuit at the expense of taxpayer dollars? Let us know your thoughts down in the comment section below, and don't forget to give this video a thumbs up while you're at it. Be sure to subscribe to the channel and hit that bell icon to stay in the loop with all our latest releases. Thanks so much for watching, and until next time, welcome to the future.